So for homework, you had two problems where you had to tell me the possible rational roots of the functions that were given to you. Now, what's nice about these two is what we went over yesterday was just the introduction. So if you notice, for both of these, our leading coefficient is 1. All right, so remember, I like to call this the PQ test, all right, because we use the letters P and Q, where P, let me write it down here so I have room. Okay, where P is the factors of the constant term, which is your last term. And the Q is the factors of the leading coefficient. So later today, oops, I didn't change the objective. Give me 1 second. So today, so yesterday and with your homework today, sorry about that, your leading coefficient was 1. All right, so you didn't have any real factors for the bottom. Later in the lesson today, we're going to take a look at what happens when that's not 1. Essentially, it's the same process, but it just gives us more possibilities. All right, so for the first one, we pretty much need to come up with the factors of 12. So again, however you decided to type it, I saw some people found a plus or minus button that you can use. If not, you could, type in each one separately. So really, we're just trying to find the factors of 12. Now be careful. Obviously, 1's always going to be a factor with whatever the number is, right? So 1 and 12. We also have 2 and 6, okay, and 3 and 4. Right. So for number 1, we had 3, 4, 5, 6, a possible of 12 factors. Okay, so plus 1, -1, positive 2, -2, positive 3, -3. Okay, so on and so forth. All right, so that was your solution, or I'm sorry, your answer to number 1. For number 2, we had to look at 16. Right, so 16, we got 1 and 16. We have 2 and 8. And then we have 4 and 4. And we don't have to rewrite that. So you could just write plus or minus 4. All right, so for the second one, you had 10 factors. Okay, positive 1, -1, positive 2, -2. Any questions? All right, so like I said, we're going to take a look at what happens when the leading coefficient isn't 1. And then we're also going to take a look at how to apply this. So yesterday I did this a few steps where we factored it, but I magically chose the right numbers. So I'm going to tell you how you can at least approximate so you're not guessing all over the place. All right, so let's look at So we have a function y equals 2x to the third plus x squared minus 13x plus 6. We want to find all possible roots. All right. So we're going to do pretty much the same thing, but now again we have more than one factor for our q. All right. So I'm just going to write so now in the numerator, we're going to write factors of 6, and then in the denominator, we're going to write the factors of 2. So I'm going to add the plus or minus, right? So factors of 6, well, obviously 1 and 6. Okay, and then all we really got in between is the 2 and 3. All right, so I have 4 factors of 6, 8 including the negatives. And now my factors of 2, well, they're not much, but it's more than 1. I have plus or minus 1 and plus or minus 2. So this is how we're going to find the possible roots. You're going to pair every numerator value with every denominator value. Right? So the way I like to do it is I like to stick with one denominator and then go through all the numerators and then move on. Okay? So first we would have 1 over 1. So that's going to be plus or minus 1. 2 over 1. That's going to be plus or minus 2. 3 over 1. That's going to be plus or minus 3. 6 over 1. Plus or minus 6. All right, so that's what we saw yesterday. That was fine. Now I want to apply the same numerators, but with a denominator of 2. So the first one I have is 1 over 2, so that's going to be plus or minus 1/2. Now here, I'm going to write it. I have 2 over 2, but when we simplify 2 over 2, that gets us 1. So I don't want to repeat it, so we can cross it out. We don't need it. Okay, it's still a factor, but it matches up with a factor that we came up with before. Right, so it repeats itself. We don't need to repeat it for our sake. Then we have 3 over 2. Well, that's a new number, so plus 3/2. And then 6 over 2, well, that gives me 3. So I'm not even going to bother writing that because we have 3. Right? So while having a new factor in the denominator does create some new roots, possible roots, okay, some of them might reappear, and we don't need to rewrite them. Okay, how do we feel about that? That's not. I don't think we took too much of a leap forward, but did that confuse anybody? Does anybody want to go over another example?
We can do one more example.
Okay. All right, so now we have 2x to the third. Actually, I'm going to change that. 4x to the third minus 7x squared plus 14. All right, so always just remember that the constant term, okay, your last term, always goes in the numerator. All right, so the factors of 14 are 1, 2, 7, and 14. The factors of 4 are 1, 2, and 4. All right, so we're going to do our possible roots. All right, so again, we're just going to match. Now, if you want to do it differently, if you want to pick one numerator and then go through all the denominators, that's fine. Okay, I just like it this way because we get the whole numbers out of the way first, and then we worry about fractions and repeating numbers. Okay, so my first denominator is 1, so I just have these. I have 1, 2, 7, 14. And then I have the 2 as a denominator, so I have 1/2. That's a new one, so plus or minus 1/2. 2 over 2, well, that gets me 1, so I'm not even going to bother writing it. 7 over 2, that's a new one. Oh no, this is my last page. And then 14 over 2, well, that gets me 7, and we already have that, so I'm not going to do that. And now we move on to 4. I have 1/4. 2 over 4, well, that gets me 1/2. We have that. 7 over 4, that's a new one. And then 14 over 4, if I reduce that, gets me 7/2, so we don't have to write that. So our last one, I'll put it over here, 7/4.
Does it matter
Okay,
if we
so
does it matter if we
does it matter if you what?
so like let's say I repeat the same would that take points off?
No, it's just it's more work for yourself. All right, and one of my key aspects, my key focuses is try to do as little work as possible. Not in a lazy way, but as in a efficient way. Okay, but yeah, if you want to write it out, I'm not gonna subtract points. All right. So now we're going to take this up to the next step, which is to actually factor the polynomial. Now, something like the last problem, these are a lot of roots to try, right? You can go through synthetic division with each one of these, but that's a lot of work, especially if you're just doing guessing and checking, right? You could go through all of these and your only solution might be 7 over 4. Or none of them may be a real solution. I'm sorry, a rational solution. We might have an imaginary number, or we might have a irrational number. Okay, so my answer might be the square root of 7. Okay, one of the zeros might be a square root of 7. So that's not going to pop up here. So what we're going to do, okay, is we may not have any, but what we can do is we can look at the graph of the polynomial to help us pick a good starting point. All right, so let's go back to the first example. All right, so we had y equals 2x to the third plus x squared minus 13x plus 6. We had our possible roots. Plus minus 1, plus minus 2, 3, 6, 1/2, and 3/2. Right? So those are the possible roots. So what you would do to factor it, okay, so you are probably going to be asked to either 1, find all zeros, or 2, find all factors. Okay, essentially they're the same thing. Finding all factors would mean we break this down to, x plus 3, x plus 2. Finding the zeros would be taking it a step further and just setting it equal to 0 and finding x equals -3 and x equals -2. All right. So what we're going to do is we're going to type this into our calculators. All right, so here we have the function 2x to the third plus x squared minus 13x plus 6, all right? And we're going to look at what the zeros are. Oh, well, look at this. They actually tell me here, okay? If they didn't tell you, you could just kind of, estimate. So here it looks like I have a solution of -3. Okay, so that would be one of the numbers I divide by. Or I have 2. Or I have, it looks like, okay, so say I didn't, I couldn't trace this. It looks like it's in between 0 and 1. So 1/2 might be a possible solution. So now you have 3 numbers to pick from. All right, so you can start with any of them. All right, so the easiest one I saw there was probably the 2. So you see that the 2's out there. The 2 is one of your possible roots. Right? So you're going to do some synthetic division with 2. 2, 1, -13, 6. Right? And just remember, we're looking for a 0 as a remainder. And if it's a 0, then we pick the right number. So we do our synthetic division. We bring down the 2. 2 times 2 is 4. 5. -3. 0. So the first number we tried was good, right? So be careful here. This tells me that x equals 2 is a solution, which means x minus 2 is a factor. So I can rewrite this as x minus 2. Now my new polynomial, well, this was 2x to the third, so this would be 2x squared plus 5x minus 3. All right, well, we saw that there could be more than one 0, right? So now I'm going to try with one of those other zeros I found, right? So 2 worked. I don't really want to try synthetic division with 1/2. So let's do -3, right? But what's nice is this is completely up to you. Okay, if you just want to go left to right or right to left, that's fine. So now I'm going to use -3 as what I'm dividing by. But again, I don't want to use that original equation. That's too much. I can use these new numbers that I found. So we have 2, 5, -3. Bring down the 2. Gets us -6 there. -1. +3, 0. So -3 is a root. So x equals -3. Or x plus 3 is a factor. And of course I ran out of room. But I'm going to write it up here. So I had x minus 2. I just found x plus 3. And I have, this was x squared, so now I drop this to 2x. Oh no, minus 1. And that is the fully factored form. And it just so happens that it's all nice real numbers. And guess what? If you solve this, you add 1 to both sides and divide by 2, you get your other factor 1/2. All right, so that's all the all the factors of our original polynomial. Okay. Any questions? Okay, so for homework tonight, you're going to try something like this. I'll try not to make it too crazy, but do the same steps that we did. All right, so find the possible zeros. Try to look at a graph. Okay, again, you have the website Desmos.com. I think it's what, Desmos calculator. Desmos.com/calculator. Okay, you can use that website. If you have an app on your phone, you can use that. So find the possible zeros, look at the graph, narrow it down, and then do division. All right, so you'll probably have, let's do this. You'll have 2 problems tonight. They'll be due Thursday. All right, so tomorrow you guys are going to work on it, and I'll be here if you need help. Any other questions?